So I decided I wanted to say a few more things about contour maps before I move on and talk about more stuff about the gradient and go into directional derivative and stuff like that. And typically, when I talked about functions of multiple variables in past years, I had gone to the library before the lecture and picked up a newspaper. But over the past couple of years, we've discontinued our subscription to the actual paper newspaper, and then this isn't an option anymore. But I'm assuming that you've seen this image that you're seeing on screen before, right? You kind of flip to the back of the newspaper in the past, and there'd been a map that showed you the temperatures, maybe in your area or maybe the whole country, and you saw the colors on it. And this is a contour map, right? Where we're using color to, kind of indicate the temperature at a given place. And so I just went and looked up the colored temperature map for South Texas this morning. And you see it's, slightly cool. And a couple of things I want to point out, that these lines that you can see, and maybe I'll get a red pen and kind of color in along this one. So you see this one that I'm coloring red over. This is the 50-degree isotherm. Okay, this line, this is a contour line. This is a level curve, right? And we say isotherm, that means same temperature. So along this line, theoretically, I'm not sure how accurate it is, but along this line, the temperature is always 50 degrees. Okay? So you see, right here, I assume we're somewhere really close to here. I'm trying to draw an arrow with my mouse. And it looks like it's 50 degrees outside, or at least it was as of 8 a.m. Central Time on this morning. And what else do I want to say about this? You'll also see these maps for pressure, right? Which, high pressure, low pressure, which, atmospheric scientists will tell you what that means for the, outlook for the weather. I don't exactly recall. But you can also see that in places where the isotherms, where these contour lines or these level sets are close together, the temperature is changing rapidly. And we're going to have more to say about this when we talk about the derivative. But I just wanted to show you a quick example of a contour map that you have seen before, and you're familiar with this concept. And, we like to, space out. It looks like on this map, they like to space it out every 5 degrees. I think that if you spread out over, the whole country, you might need to, draw your lines every 10 degrees. Because, you could draw this as detailed as you wanted, right? You could draw this every degree or every 1/10 of a degree. But then your map would get all cluttered up with all these lines. Okay. And then we use color, and then the color helps even more because, we have kind of an intuitive idea about cold colors versus warm colors. And you can see that as we go from out here in West Texas, out where it's really freezing, all the way down to the beach where it's much warmer, we're seeing that the colors are warming. And so this is just one quick example of a contour map, because I was realizing in the video I recorded last time, I told you about a contour map, and then I drew you one pretty bad one, but I didn't call back to the classic example of a contour map that you're familiar with.